So, back in 2017, there was a UNLV ECE project called the 3D Room Scanner. My team, consisting of Anna Yelly, Louise, Josh, and myself, Ken Puck, really liked this project, so we stole the idea and decided to revamp it 5 years later. This is the 3D Scanning Rover. Whether for indoor or outdoor use, the 3D Scanning Rover seeks to traverse and provide high-quality 3D scans of any given area for the sake of analysis, design, or modification. It combines the mobility of an all-terrain rover with the 3D scanning capabilities of traditional 3D scanning devices to create a hybrid capable of doing both at the same time. The 3D model results are then displayed to the user's computer. For market alternatives of this prototype, if you look up 3D Scanning Rover on Google right now, you'll see the Planetary Rover 3D Scanner by NASA. This thing functions similarly to what we're trying to provide, except it's not commercially available. Okay, so something else consumers might look into are handheld 3D scanners. These have great preciseness on 3D scans, however, if you have an area like a cave that has low oxygen content, it might be too dangerous to send someone down there with a handheld scanner. Another option is a rover with a camera. This works great as well, similar to what we have, but the videos and images it provides are not 3D scans and are not as versatile. Lastly are the 3D scanning drones. These are pretty much the same as ours as well, except they only are able to provide aerial views of the areas scanned, which means that they're limited by that aerial view. So once again, if you have a cave or a tunnel system, then it won't be able to enter that. And thus, it follows that our goal is to prototype a device with the capability to both 3D scan environments and have ground traversal for a one-of-a-kind product on the market. When designing the rover, we had two main considerations, that being the all-terrain design and the computing design. On the all-terrain side, we had a custom chassis design built by Anna Yelly and her father, pneumatic 6-inch tires to ensure that we had good clearance from the floor, an Element 6 radio control to allow the user to give movement inputs, and a Roboclaw 15 amp motor driver, which allows for power allocation to each of our motors from our batteries. On the computing side, we have our main computer, the UP board core, as well as our main 3D scanner, the Intel D435i depth camera, and finally our main communication protocol through SSH on a TP-Link AC750 travel router. The first result from the 3D Scanning Rover is a 2D map of the areas that the rover traversed. On this one in particular, you can see the white dotted line showing the exact pathing of the rover, as well as each of the hallways that the rover managed to go through. Now, for the main output results of the 3D Scanning Rover, we have the 3D model. This is formed using the Intel D435i's depth camera RGBD data. That means red, green, blue, and depth data. Now what the camera does is that as it goes through a space, it can look at a point in space and say, that's red, that's 2 meters away, and it will put down a dot that's red and 2 meters away in the 3D space. And when you get enough of those dots, then you get something that looks sort of like this. This is called a point cloud, and it looks vaguely similar to what we're trying to image. However, if you were to play a connect the dots in 3D space, it will look something like this. This is called a mesh. A mesh is the general shape of everything that we've traversed with our rover, and from there we can take images from the camera and apply those to the mesh, creating a texture mesh. And while texture mesh has its problems with reflective surfaces, it's able to better reflect some of the finer details on the walls and doors and such, and even in the background and foreground of the below picture. Now, you might be looking at this project thinking, how does this help anyone? It drives, it scans, and that's about it. But if we look at the models and maps that this robot can provide, then we can see a couple more use cases. One I mentioned earlier is that it can go through caves that are difficult or dangerous to traverse for us, and be able to 3D scan it. Another one is land surveying, where if you don't want to allocate an entire person to 3D scan an area, this rover could do so autonomously. With some features we want to incorporate in the future, such as map-assisted navigation, where you can point to a spot on a model or map, and the rover will traverse there, There's a couple more things that you could do with this as well, such as robot servers in restaurants, casinos, or hotels, or even transporting supplies across a worksite.